Okay, good morning, everybody. So I'm Thomas Monjalon. I work for Mellanox, and
I'm Jeff Guo, a DPDK developer, work for Intel and come from China.
okay. Before you see, so it's like a community presentation. Chizong participated to the slide, but unfortunately, he's not here to present. Before starting, I want to check something. I would like to see who is attending. So please stand up and stay when you hear your company name. OK? Let's try that. Mellanox. Stand up, please. Cavium. NXP. Ericsson. Red Hat? I can say. OK, right. ARM? Yeah, people from ARM. Oh, and this year, exceptionally, we have some people, they take a break from fixing security stuff. There are few people from Intel in this room. No? Oh, nice. Wow. You got a discount price? Oh, it's free. I see. That's right. OK. And there are a lot of other companies. So everybody, please stand up for the DPDK community. Thank you. Great. OK. It's time to start. So, excuse me. So the presentation is about Hotplug, basically, and more generally, get an overview of what is device management and dynamic device management in DPDK. First of all, at the origin of DPDK, everything was static. The CPU, and it's still static. The memory, it got dynamically allocated thanks to Anatoly, mainly in 1805. And there is also a work in progress for a long time to get some Hotplug support. So we will talk about that. OK, first, it's important to understand, as an overview, what are the layers in DPDK. You see, at the top of the sandwich, you have the application. It's very important to understand that the application takes the decision. It has the control. Then, at the bottom of the sandwich, you have the buses. Now we have several buses. And in the middle, the devices management. What is a device in DPDK? You have the device resource, which is canned in EAL. You have the driver, which use these resources. And on the top, the ports, some class interfaces. The ports can be ethdev, the most known one. And there is also baseband, crypto, compress, dev, event, and so on. It's very important to understand that the only part in DPDK which makes the bridge between the device resources and the device interfaces, the port, is the driver. Okay? Only the driver knows how the resources are connected to the ports. And it's especially very important to understand when you see that there can be several ports for one device resource. OK. So buses, now we have a lot of buses. As you can see, historically, we had only PCI. Now we have more. And because of that, and also for other reasons, we need to extend the syntax to describe the bus and the devices. Because before, we had only a syntax to describe a device by its PCI ID. And we extended it a bit to have a way to name the virtual devices. But now we have more. So here you can see a proposed syntax for devargs, where there are three parts, one for the bus, one for the class device, where we can put some options, and one for the driver, where you can have more specific driver options. This syntax got some early work in 1808 to be parsed, and now it's time to implement it with all the properties we want to see with this syntax. And when it will be implemented, we can imagine use maybe a new option with this syntax to replace the vdev option and the whitelist options, which is the first user of devarg syntax. Okay, talking about whitelist. This is blacklist whitelist. It is also something which is very static in DPDK. What is doing blacklist and whitelist? It is controlling what is probed. But we can maybe try to make it more dynamic. Maybe we want to update what is blacklisted and whitelisted during the lifecycle of the application. So we will need to think about a new API. It's not done yet. I see two options to implement it. Either we ask the application with a callback what should be scanned, what should be probed, or the application can try to update some list inside DPDK. It's the opposite way. Okay, now let's talk more about Hotplug. Okay, it's a kind of mess, but it's going to be better sorted now, more and more. So initially, we had an API in ethdev, which is ethdev attach. And you see, in this API, you have two parameters. One is devargs, which represents the device resource in EAL. You remember the bottom layer and the sandwich. And the other argument is the port ID, the upper layer, the device interface. So it's just wrong by design. You cannot match one device resource and only one port. It can be several ports. It's just wrong. So now it's deprecated. We have also, so this API was introduced only for when we introduced vdev. Then we introduced another API inside EAL, which was mainly at the time when designing failsafe. And here you just give some devargs, but this API was supporting only the syntax for PCI and vdev. And anyway, it's also deprecated because we have one more API, which is RTEL Hotplug add. Hopefully, it will be the last one. Not sure. But it can be simplified. We have too many parameters. It can be just one parameter for devargs, and that's all. You see, with the new devarg syntax, you can describe everything. And it's very explicit syntax, so you don't need more. Another change to do in this function is that now, with the new syntax, one string, one devargs, can match several ports, several devices, excuse me. So it means let's say I probe 10 devices at the same time, but two of these 10 devices were already probed. What happens? Should it be an error? No, obviously not. I'm just adding more devices to be probed. So now we need to skip the probe devices when probing more. Okay, it's a discussion about the syntax mainly. Now, the same thing for removing some ports. So maybe the application just wants to remove a port, not necessarily a hardware device. The application sometimes does not know the hardware device. So you just, what is the best API to close a port? Obviously, it's ethdev close. Currently, it's not really used like that because the close function is not fully releasing the port and it's not releasing the hardware resources. But it can be improved. And from EAL, we have an API, Hotplug remove, which is ready to remove the hardware resources. And obviously, when removing the hardware resources, you trigger the removal of the ports. OK, what else? How does it work? we have a lot of notification. You remember the application at the top must control everything. How the application can control, the application must be aware of what happened. So we send some events to the application with the event callback. We have some events at ethdev level, when you have a new port and when a port is destroyed. We have, at the ethdev level, we have also another event which is interrupt removal, RMV, which say this port is not removed logically in DPDK, but in fact, you cannot use it anymore because probably someone removed it physically. Okay, so you need now to remove it logically and stop trying to pull this device. This event was introduced when doing failsafe, because with failsafe, when one device is removed, you can fail over on another one. And you have also the hardware events that you get from the kernel with U-event. And when you get such hardware event, probably you want to notify the application that something happened. So there is an event add and event remove events. How these events coordinate? So when you have a new device, you receive the hardware event. The application receives the hardware event, and then the application decides to call the function hotplug add at ERL level. Then the PMD do its work, and at the end, the PMD send again a new event to the application. So at the end, the application knows there are some new ports. Same thing for unplug. You receive an hardware event, the application receives the event and decides to call the hotplug remove function. Then we do the work, there is something to improve there. And at the end, the application receives an event to close the port and stop polling this port. And you see also there is what I already explained with remove event. Okay, but maybe we'll talk more about it later. Okay. So now we'll talk more about what happens when you have a device which is physically removed, hot unplug. So in the Mellanox case, we are able to get to know that the device is not usable anymore. So there will be no crash, no failure if you continue to poll. It's just blocked at some layer, and you receive the event, removal event. But in the generic case, you should not try to write to a device which is not there. And that's why Jeff is working on some things which is pending for the next release, so he will explain.
Okay, so the subject of this part is the Hotplug hardware event. So I would like to talk with you something about many types of Hotplug hardware event and how to process this Hotplug hardware event. So this part of the topic is focused on the two-stage. That is the U event detection and issue the application callback of the Hotplug's holy sequence, as Thomas said before. So when you're seeing this picture, I think the proposal is coming. So the first, the event, DPDK is diversity. It supports several hardware, kernel driver, and platform. So the hardware events should be diversity. So it could be and should be managed by the Hotplug framework. So this is the first. And secondly, you know, the kernel processes Hotplug and then invoke the user space to process the Hotplug. So these two tasks is independent. So framework can help to decoupling this segment task, such as like this picture, the bricks is deliver from the one stage and then to the other stage. So it is independent. So third, framework can provide service for taking over the control at some breakpoint, such as Hotplug in and Hotplug out. At this time, the data path is changed to the control path. So, and you don't need to worry if this service will overload the DPDK, since if you don't do that, the application will crash. So in this time, the framework should be in charge of that. So this is a proposal, okay? Okay, so let's see what's going on for the hardware event and the handler. As we said before, we have a multiple device such as PCI device and virtual device, and support UIO PCI kernel driver, VFIO PCI kernel driver, and often the OFAC kernel driver. So there are many developers work for that, for the specific Hotplug solution. So for example, the Microsoft implement the Hyper-V and VM bars and UUID and NavVSC PMD. So they have implemented their specific Hotplug handler in the use of the cloud business. And yes, for the OFAC kernel OFAC case, so the Hotplug handler should be located in the OFAC kernel driver, and then it used the IBV event to identify the Hotplug hardware event and call back the application to do the Hotplug process. So, but for the UIO PCI and VFIO PCI kernel driver, we can use the U event in Linux to identify the Hotplug event. Maybe VFBSD have another event, we could implement it. And so we identify this event, we need to process it. So because the UIO PCI and the VFIO PCI have different mechanism of Hotplug in the kernel driver. So for the UIO PCI, we can detect the signal bus error and use the bus failure handler to handle the Hotplug. I will detail it in the next page. And for the VFIO PCI, it had a special mechanism to guarantee the device will not delete in the kernel side until the Userspace release the resources after the user side. So we should detect this new release required notify interrupt. Okay, this is the one idea. And the second idea is that since DPDK is diversity, so each vendor and kernel driver could have its Hotplug handler here, or there. But if in the framework side, up the framework side, they should come across the common event, just like the EAR device event, to let the application to register these events call back. So I think this is framework mindset, and it will let the life is easier of the user. Okay, so we can see this is most focused on the Hotplug out handler, and also I have we will have a Hotplug add handler is in another topic. Is still discussing, just like Thomas said before, the plumbing handler. Okay. So this is the details about the UIO and VFIO PCI Hotplug failure handler. So you can see there are two NICs are working, and NIC 2 suddenly broke. At this time, the data path is fast, since the data path is faster than the control path. So it still tries to access this device resources, but the device is already not exist. So it will issue a signal bus error. This is evoked from the kernel side. So the signal bus handler will be invoked. This handler will check if this is a generic signal bus error or a BARS signal bus error. By iterate all over the bus to find the following address is located in each device resources range. If it finds it is the generic signal bus error, it will call the generic signal bus handler, default signal bus handler. But if you find it is the BARS signal bus error, it will call the failure handler, the memory failure handler. So the memory failure handler will guarantee the rest memory access will be safe. So by such as remapper anonymous or fake memory, and then guarantee that the rest access will be safe and give the time to let the applications call back to release the device resources in the upper layer. So this is the UIO Hotplug state progress. It is 1, 2, 3, and 4, 5, 6, 7 step. But the VFIO, as I said before, it has special mechanism. So VFIO kernel driver send a release request at first, and keep on monitor the device status. If it find the device is released by the up layer, the Userspace, it will delete the device. So the step should be 1, 2, 3, and 7. Okay, so these proposals patch and is on reviewing on the community. So if you are interested about this topic and have good suggestion, you could email me or by any social way to contact me to discuss about it. Thank you. Okay, Thomas.
Thank you.
Okay.
Okay, let's see another problem with Hotplug. It's not so easy to do Hotplug when you are using multi-process application. Okay, this part is the work from Chizong. I pronounce it correctly? Chizong. And it's also pending for 18.11 release. So what is a multi-process application? You have several processes. Okay, until there it's okay. And how do you tell to the other process that you have a new device? We have a new multi-process communication channel, IPC channel, which is used there to broadcast some messages about Hotplug events. And there is also a system to roll back. If one process has a failure, you need also to do the rollback on the other process to be consistent. With this system, all process knows all the devices. So we don't need anymore to have the kind of private virtual device we had before. And it works also when a device is removed for unplug. You remove a device in your process, then you communicate to the other one, you remove the process, and the last process removing the device will completely destroy all the data for the device. How it works? It's complicated. So you can see, okay, I will try like that. When we attach a new device, we send a message to the other process. There is a thread for that. Here you have a handler, and you cannot directly reply to the other process for implementation reasons. So we use the interrupt thread to defer the reply here. Then we check if everything was OK. If not, we need to roll back. If it's okay, if it's not okay, if we need to roll back, we send another message. This is the blue message. You have here a rollback handler, and again, for the same reason, you need to defer the reply to the interrupt thread, and then you send your reply to the primary process. This one is a bit not so complicated, but if you are attaching a device from a secondary process, given that the primary process is managing the device database, it's a bit more complicated. I won't go into details here. You see, it's more messages, more messaging, more threads. Okay, so this is a work in progress, and we hope to have it in 1811. And probably there will be more works to do later. First, there is a reliability issue. And I think Anatoly is working on it partially because he's implementing a new API to reserve some shared memory. It will solve some issue for this multiprocess Hotplug. What else? There is some code to clean because we have a separate thread to reply to the request. And we will need to expose in the driver which drivers support the capability of hot plugging a device in a multiprocess case. And we have also an issue for unplug because for now, we don't really know who is responsible for the device, if it's the primary process, the secondary process. And maybe we can have a kind of handshake to ask between all processes if we agree to free a port. And maybe this issue can also be solved with the help of the ownership concept. I will talk about it later. Okay, now I want to explain how we solve another issue, which is device migration. So at first, it is an issue at ethdev level. When one device disappears, are we able to switch to another device? This is the first question. And second question is, are we able to switch from one process or from one VM to another one? We know that one driver which is really capable to migrate from one VM to the other one is VFIO. And there are more. For instance, in Hyper-V, we have NetVSC, which is the equivalent of VFIO. But so anyway, we need to use this kind of virtual device to do migration. So one solution is to bond your hardware device with the virtual device, VFIO or NetVSC, and you manage to switch from one to the other before doing the migration. There is another solution, another driver in DPDK, which is called failsafe. It's basically the same idea, but there are a few differences in the implementation. For instance, all the sub-devices in a failsafe pair have the same configuration. It's enforced inside the behavior of failsafe. And one other difference is that you don't see the sub-device of failsafe from the application point of view. So it is a bit more transparent. And why you don't see them? Because there is a new mechanism introduced to manage port, which is ownership. With ownership, we can say these devices are sub-devices for the failsafe device. So you don't need to see them. Failsafe owns these sub-devices, and the application will see only the failsafe device, the top-level device. Okay, a bit more about ownership. So ownership should be set when you receive the event of a new port. So you like failsafe, like the application can register to the event to get a new port. If it sees that this new port should be part of the failsafe device, okay, it sets the ownership to him. And there is a lock in ownership mechanism. So this is only a convention, but to know who will manage a port, who will configure a port, we can say only the owner of a port will configure it. But it's not enforced inside DPDK. There is no log for that. Like, you know, there is also no log for polling a port, but you poll a port from only one thread. Otherwise, you will have issues. OK, I will go faster. There is something else important when managing devices, which is to know what are your devices, to iterate over them. Until now, we were using the function ethdev count. But it's wrong, because when you have Hotplug, you can have some port IDs which are not allocated. And it's also wrong because it's not using through the ownership mechanism. So now we have a new system with new macro, which are eth for each dev. It's only for ethdev. And because of that, the function ethdev count will be removed. There is an equivalent one. But it will enforce every application to switch to the new eth for each macro. So you see there are a lot of mechanisms to manage port in ethdev. We talked about ownership, iterator, all the events at ethdev level. There is also some failover with failsafe and bonding, but we have nothing of that for other device classes, baseband, crypto, compress, event. They are not Hotplug proof. So we have still a lot more work to do. The good thing is that we are opening the way with ethdev. It will be easier later for other device classes. OK, thank you. It's time for questions. Yeah, Declan?
So just on the very last slide there, the iterators and ownership, those all look like they're very device generic. They're like there's nothing really explicit about ethdev. Should we be doing them on at a lower level? Because
yeah,
I
remember you proposed maybe 2 years ago to have a generic class for all device classes, and it would solve this issue. Indeed, we decided to not go this way and have only specialized classes. It's a different implementation. So now the question raised again, how can we have a common code for all this stuff? I don't have an answer today, but part of the answer is now we have a RT class which represent ethdev crypto, all the classes. How to use it to put iterators, other thing in it. We'll see. We are not using C++, unfortunately. Yes, Stephen?
I was just going to say, I think we're at least a couple releases away from getting to the point where we're going to have to give up on having an array of ports and a port ID, because the current model is so limiting as we try to scale up to layered devices and more stuff. If you start to talk about having a device layered on something else on top of a tunnel, on top of a crypto device, then having devices with port IDs just starts to get ridiculous, especially if you're going to start allocating them and trying to manage them as a tree of devices.
I don't get the question.
I'm saying that how do you think the APIs would evolve if we got rid of port IDs or not using them as directly accessible?
If we decide to stop using port ID?
In other words, instead of having ethdev count, at some point, ethdev count becomes 1,000. Yeah. Yeah. I mean, at some point, we're going to have an ABI breakage, is the way I'm thinking. I mean...
Yeah, it's breaking. On purpose. On purpose, because, okay, so you're talking about this slide, right?
Right.
Okay, we have a safe solution to iterate over devices.
Right.
It works.
Right.
Because what it's doing some state and skipping the port ID which are not allocated. The issue is that everybody is used to this solution.
Yeah.
How do we enforce everybody to switch to the new solution? We claim it, we document it, we send some emails, and at the end we discover that nobody did the switch.
I mean, do we have to deprecate ethdev count at some point so that you know,
it's a way, because your application won't compile anymore.
Yeah.
So what do? You check the documentation. What happens? Who killed my application? The answer is me. Okay. And when you will discover what is broken, you will see the small part of documentation saying, use this one. And at the same time, if you really need to know the count of device, the ports allocated, you will have another function, which is count total, something like that. But most of the time, you just want to iterate.
Those aren't, sorry, those aren't an ABI though, those are an API. So like whatever they're calling underneath, you will need to protect, like those have to be the actual binary interface contract to the...
I don't understand, excuse me, could you?
Those iterator macros, they're like, if you change, you know, the function signature, the function that they're calling, the application that's linked isn't going to get an update to it, so it's not much safer.
Yes, yes, you're right. This macro is only to iterate at a given time. And if you want to be updated, you have the events. So usually, when you do this kind of iteration, you are in a state where you know that nothing happened. But if you have a hardware Hotplug, a new device, yes, there can be, let's say, a kind of race. But you will get the event, so you will know, oh, I have to iterate again. Maybe, something like that. Does it answer? Yeah. Okay, Bruce?
I just have a couple of questions on it was thinking particularly of the slide where you step through the procedure, the process for adding a device and removing a device. It's quite a bit back in the talk, but...
This one.
Yes. So the first thing that struck me about that is in the unplug there about how the application calls RTE-EAL hotplug remove. If a device is just being plugged out of the system, what happens if the application doesn't call that? And why are you leaving it up to the application when it shouldn't really have a choice? It gives a nice symmetry, but I'm just wondering for the remove stuff,
it's one answer.
should we perhaps not have the application quite so much in control? Inform the application, but if something's really gone, we should probably just do what needs to be done and leave it at that and say, okay, this is gone, application, do whatever you want. So that's the first thing. If you have any comment on that.
Okay, first answer is I don't know better than the application. You don't know. If the application knows that you unplug and you replug just after and it wants to keep it for some time, I don't know, you can imagine anything. But
that assumes then the application knows better than the kernel that's just sent you the event saying this piece of hardware is gone.
Yeah.
I mean, there's some things perhaps that the application shouldn't be given the choice about if it doesn't make any sense.
Is DPDK a library or a service?
So basically what you are saying is that when you send this event, you could directly call the function without asking the application to do the call.
Yeah, I'm asking when would it make sense to prevent the application from calling that if something is really gone?
Yes, it's right. We can discuss it. It can be changed, but it's like you said, it's a matter of symmetry. We can also think if an application doesn't want to manage Hotplug at all, an application which is not Hotplug proof. You won't have the call to Hotplug add. So why should we automatically call Hotplug remove if the plugin is not managed?
Because it'll crash your application,
Yeah,
right? If it
because-
tries
yeah,
to
yeah, yeah.
access something that's not there. I mean,
Yeah.
safety. Okay.
So
we
the
better
answer is,
pass on
basically
discussion
the
on
answer
this.
is that I agree with you. It's a proposal, and you can change it.
The other, if I have time for one more quick question, just for the add, I'm just wondering about the role of the systems administrator rather than the role of the application. You know, with this is the application being informed about it, but at what point in the process does the guy who's running the system get to decide as the system owner whether a particular port should be belonging to DPDK or not? What would you envisage as a mechanism for that happening? You know, how does the system administrator control when he plugs in a network card whether that goes to DPDK or not?
It doesn't solve this question on purpose, because is it the responsibility of DPDK to solve the administrative question? But by pushing it to the application, it's a way to pushing it to more
right, it's pushing it to the
frameworks.
application, but if you get an application that just accepts every port that's offered to it, how then is a guy who's administering a system able to plug in a network card and not have DPDK take control of it? You know, you're assuming the application writer is going to do the right thing, rather than taking it into account, saying, okay, well, maybe it can be controlled via UDEV rules that prevents a U event being sold. So it's another thing perhaps we need to take into account.
There are UDEV, there can be other framework in Windows, in BSD. We can think about some policies in OpenStack or other things.
Yeah. It's just this is kind of assuming that all applications are going to be well behaved.
Yeah, what we can do is to provide some helpers to the application in order to use all this framework, like UDEV.
Okay, but how do you make sure the application will use them? How do we make sure that we don't end up with malicious applications?
Should we have to make sure the application will do the right thing?
It's probably something that needs some offline discussion. So we have one more presenter, and then
Steve?
we have to go for lunch. So I suggest we leave that there. Thanks, guys.
Thank you.